This is Year 14, A22Physics 5, and this is a podcast on the past paper solutions of capacitors from 2004 to 2009. The first question here then is from A22Physics 5's May 04, and question 2. A capacitor of capacitance C is connected to a supply voltage which is gradually increased from 0 to a maximum value V max. At a particular instant, the potential difference across the capacitor is V1. Write down an expression in terms of C and V1 for the energy E1 stored in the capacitor at that instant. So that's just your equation, except that you're putting V1 and E1 into it. So that's going to be a half C, and then rather than just V squared, call it V1 squared. And that's 1 mark. On figure 2.1, sketch a graph to show how the energy E stored in the capacitor depends on the supply voltage E. Now you know, if I just write down at the side here, that E is proportional to V squared. So if you were to plot a graph of E versus V squared, you would get a straight line through the origin, but the graph you're going to plot is E versus V. So therefore that is a graph which is going to be a curve, and it's an upward curve like that, and it has to end up at your V max value. So if you factor that in as you're starting it, and that's your curve there. Part 2 of the question, the capacitance of the capacitor is 20 microfarads. Over a period of time, as a result of changing the supply voltage, the charge in the capacitor is raised or increased from 40 microcoulombs to 170 microcoulombs. Calculate the range of the supply voltage which produces this change in charge. And so all you really have to do is do a calculation twice and calculate the voltage for each charge there, and you know that the capacitance is constant. So our equation for capacitance is Q over V. So therefore, if you rearrange that, we're looking for V. So V is equal to Q over C. And so we're going to do 2 calculations. The first one is going to be with the 40 microfarads, so it's 40 by 10 to the minus 6. And that's divided by 20 microfarads, 10 to the minus 6. And that gives you 2 volts. And then we're going to do a second calculation. V is equal to, this time we're going to use 170 microfarads. Remember to, or don't forget about the minus 6. Although in this case you would get away with the minus 6 because there's also minus 6 in the bottom. And if you forgot it, you'd still end up with the right answer. If you got it in both cases, of course. And that gives you an answer of 8.5. So the range of voltage then goes from 2 up to 8.5. And that's for 3 marks. Part B. And this is part 1 of B. A capacitor has a capacitance C and carries a charge Q. Write down an expression in terms of C and Q for the energy stored in the capacitor. Now we wouldn't, normally the 2 equations that we give you are E is equal to, pull it down a wee bit, half CV squared, and the other one is equal to a half QV. So really what we have to do is get one then in terms of Q and C. So probably the easiest thing there to do, we have to get rid of the V in each equation. So we know that V is equal to Q over C. And therefore we need to put V squared in there. So V squared is equal to Q squared over C squared. So therefore if we have half CV squared, if we use that first expression, half CV squared, that's equal to a half C, and then Q squared over C squared. And so that's going to go out. And so your answer then is a half Q squared over C. The other thing that you could do is just learn that as a third equation. It's up to you what you do. Part 2. Figure 2.2 shows 3 capacitors of capacitance 2 microfarads, 4 microfarads and 8 microfarads, and they're connected in series to a battery. Which of the capacitors has the least energy stored in it? This is the next part of the question. Indicate your answer by putting a tick in the appropriate box and explain your reasoning. So there's 1 mark for the correct tick and 1 mark for the explanation. If we just write down the equation again, E is a half Q squared over C. So very often they'll ask the first bit of a question and that leads you into the second bit, and you probably have to use this bit. So half Q squared over C. We know that because they're in series, all capacitors have the same charge across them. And the reason is because in a series circuit you have the same current flowing around the circuit. So you have the same charge across each capacitor. So if the charge is the same in each case, then it means that the one with the biggest capacitance is going to give you the smallest energy value. And so the answer down here is going to be your 8 microfarad capacitor. Because whenever you divide your Q squared by 8 compared to Q squared divided by 4 or 2, you're going to get the smallest answer. So the explanation, just use the equation and the explanation. We know that A is equal to half Q squared over C. But then explain Q is the same across each capacitor in a series circuit. Therefore, the largest capacitance will give the smallest energy from the calculation. Okay, and that's the end of that question, which was male for